Picture the ocean, a vast, seemingly endless expanse of blue that covers more than 70% of our planet's surface. It's a world of breathtaking beauty, teeming with mysterious life, and holding secrets in its deepest, darkest trenches. But for all its complexity, one of its most defining features is something incredibly simple, something you can taste with a single drop: salt. That unmistakable, briny flavor is the signature of every ocean on Earth. It's so fundamental that we often take it for granted. But have you ever stopped to wonder? Think about the water cycle we all learned about in school. Water evaporates from the ocean, forms clouds, and then falls back to Earth as rain. This rainwater fills our rivers and lakes, and it's fresh. You can swim in a cool, clear lake without that stinging sensation in your eyes. These very same rivers flow day after day, year after year, eventually pouring their fresh water back into the sea. So, if fresh water is constantly being added, why doesn't the ocean become less salty over time? Why is there this stark difference between the water that flows over the land and the massive bodies of water it flows into? It's a fantastic question, and it points to a fascinating story. The answer isn't a simple one. It's a grand geological epic that unfolds over billions of years. It's a story that begins with the fiery formation of our planet and continues with the slow, patient work of rain and rivers, tirelessly breaking down mountains, grain by grain. We'll see how these rivers, despite being fresh, are actually the primary couriers of salt, carrying tiny dissolved minerals on a one-way trip to the sea. And we can't forget the dramatic role of underwater volcanoes and hydrothermal vents, spewing chemicals directly from the Earth's mantle into the deep ocean. It's a complex interplay of forces, from the smallest raindrop to the largest tectonic plate, a puzzle with pieces scattered across the entire history of our world. Are you ready to put them all together? Then let's dive in. Welcome to WhyOWhyTV. That's WhyOWhyTV, the show that explores the biggest questions about our incredible universe. Have you ever wondered why the ocean is salty, but the rivers that flow into it are fresh? The story of ocean salt is a grand planetary tale that unfolds over millions of years, starting with a single raindrop. It all begins in the atmosphere. As rain falls, it's not just pure H2O. It absorbs carbon dioxide from the air, and through a simple chemical reaction forms a very weak solution of carbonic acid. Now, this isn't the kind of acid that would burn your skin, but over geological time, its effect is immense. When this slightly acidic rain falls on land, it acts as a slow but relentless solvent. It seeps into the ground and flows over rocks, chemically breaking them down in a process called weathering. As the acid dissolves the rock, it leaches out minerals, releasing them as charged particles called ions. These ions, including sodium and chloride, the two components of table salt, are then carried by groundwater, streams, and eventually mighty rivers on a long journey to the sea. Every single river on Earth acts like a conveyor belt, delivering a constant, tiny trickle of these dissolved minerals to the ocean. While the concentration in any one river is too low for us to taste, the combined flow from all continents adds up to a staggering 4 billion tons of dissolved salts delivered to the oceans each year. But that's only half the story. The ocean floor itself is another major source of salt. Deep beneath the waves, seawater seeps into cracks in the Earth's crust. It gets superheated by magma and then erupts back into the ocean through hydrothermal vents. This scorching, mineral-rich water carries a heavy load of dissolved solids directly into the sea. Undersea volcanoes also contribute, spewing minerals from the planet's interior. So, with all this salt pouring in, why isn't the ocean getting saltier? Because it's a two-way street. Salt is also constantly being removed. Some ions are used by marine organisms to build their shells and skeletons. Others react with the seafloor to form new minerals, or get trapped in sediments. When ancient seas evaporate, they leave behind vast salt deposits. This incredible balancing act between input and output has kept the ocean's salinity remarkably stable for hundreds of millions of years. Rivers flow continuously, cycling fresh water back out. Oceans have no large-scale drain. Minerals accumulate. Over time, salt levels stabilize at about 3.5%. Fun fact: if all the salt in the oceans were spread across Earth's land, it would form a layer about 500 feet thick. Not all salt comes from land. Underwater volcanoes and hydrothermal vents constantly spew minerals into the sea. These minerals enrich seawater chemistry and add to its saltiness. The oceans weren't always salty. Early Earth's water cycle was different. Scientists believe early oceans were much less salty. Over billions of years, salt built up to modern levels. Salt helps regulate the entire planet's climate through a process known as thermohaline circulation. It sounds complex, but the name gives us a clue. Thermo refers to temperature, and haline refers to saltiness. Together, these two factors determine the density of seawater. As polar ice forms, it leaves behind highly concentrated, super salty, and intensely cold water. This water is incredibly dense, so it sinks to the ocean floor, kicking off a massive, slow-moving current. This deep water then travels for centuries along the ocean bottom, a vast, silent river within the sea. This is often called the global ocean conveyor belt, and it's the planet's circulatory system. It transports heat from the equator to the poles and brings oxygen-rich surface water down to the deep sea, supporting life in the abyss. Without salt driving this engine, global weather patterns would be unrecognizably different. And it's not just the climate that depends on salt. Every creature in the sea does too. Marine life is intricately tuned to a stable level of salinity. This is because of a fundamental biological process called osmosis, the movement of water across a membrane from a less concentrated solution to a more concentrated one. The cells of a fish, for example, have their own internal salt balance. They are constantly working to keep that balance just right compared to the water around them. If the ocean suddenly became much less salty, water would rush into their cells, causing them to swell and burst. Conversely, if the ocean became too salty, water would be pulled out of their bodies, leading to fatal dehydration. Every single marine organism, from the tiniest plankton to the great blue whale, has evolved sophisticated mechanisms to manage this delicate osmotic dance. This is why even seemingly small shifts in salinity can have catastrophic effects on entire ecosystems. Coral reefs, the vibrant cities of the sea, can bleach and die if the water becomes too fresh or too salty. But to see a truly dramatic example, we can look at the Dead Sea. With a salinity of over 34%, it's nearly 10 times saltier than the ocean. This extreme environment is hostile to almost all forms of complex life. There are no fish, no plants, no seaweed, hence the name. The water is so dense with dissolved minerals that people float on its surface effortlessly. The only things that thrive here are a few specialized types of bacteria and archaea, known as extremophiles. The Dead Sea is a stark reminder of how salinity dictates life. It's a powerful illustration that the ocean's specific saltiness isn't just a characteristic. It's a prerequisite for the abundant, diverse life we know and love. So when we look at the ocean, its saltiness tells the epic story of our planet. It's a story that begins with the very formation of Earth. For billions of years, rain has fallen on the land, weathering down mountains, dissolving rocks, and releasing their mineral salts. Rivers, acting as the planet's veins, have tirelessly carried these dissolved ions on a one-way trip to the sea. Meanwhile, deep beneath the waves, hydrothermal vents on the ocean floor have gushed superheated mineral-rich water, adding their own unique ingredients to the mix. And all the while, the sun has been patiently doing its part, evaporating pure water and leaving the salts behind, concentrating them over geological time. It's a dynamic, ongoing process, a perfect, planetary-scale recipe that has been simmering for eons. So the next time you're at the beach and you feel the sting of salt water in a cut, or taste that familiar tang on your lips, take a moment. That tiny crystal is a piece of history. It's a relic from an ancient mountain range, a whisper from a deep-sea volcano, a traveler on a billion-year journey. You are, in that moment, connecting with the immense, slow, and powerful forces that have shaped our world. You're tasting a story that's dissolved in every single drop of the ocean. And that is the profound story hidden in something as simple as a salty taste. Here at WhyOWhyTV, we believe that every why leads to a world of wonder. If you agree, and you want to keep exploring the fascinating answers to life's biggest and smallest questions, make sure to subscribe, because the more you ask why, the more you discover.